Am I starting the recording? Today is 26th October 2020. We are in chapter 3 on resistive network. Okay, everybody, what call it? Have the slides that I posted on this MS Team. Have everybody downloaded the slides? The slides, what call it? I have not done any modification because they're still applicable, and you can use that slides for your revision, and also you can use the textbook. Okay. So now I'm going to share the slides presentation for our lecture today. Okay. Everybody see the slides? Chapter 3, Resistive Network Analysis.
Yes, sir.
Yes, sir.
My voice is clear. No interruption. No what call it, delay.
Clear, sir.
Okay.
Yes, sir.
If there is not clear, whatever you just mention to me. Okay. So today we are going to go into network analysis. We are going to start the network analysis. Last week we cover the Ohm's law, we cover the Kirchhoff current law, Kirchhoff voltage law. We cover on how to calculate the parallel resistors and how to calculate the series resistors. Okay, so all those formulas that you need to use for this lecture, for this part of the lecture, we will use for the resistive network analysis, and also for the next week. For the next topic will be on the AC network. Okay, so what is a network analysis? Network analysis is essentially the process of determining each of the unknown branch currents and node voltages. So basically that network analysis is a method, a process that you do in order to know or to calculate the currents and voltages, the current of the branches and the voltages at the nodes. Okay, that is a simple definition of network analysis. And this process actually requires a few methods that you're going to use. The general methods for the analysis of electrical circuits are, so we have about 5 methods. The first one, node analysis or nodal analysis, or call it a node voltage method. During my time, we call it nodal analysis. Now we call it node analysis. Second one is mesh analysis or mesh current method. The third one is a principle of superposition. The fourth one is the Thevenin's theorem, and the fifth one, Norton's theorem. So we have all these 5 methods that we are going to use. It can be a combination when you want to solve the problem. It can be a combination of all 5. It can be only one method. So it can be many ways. So one network you can solve using any of these 5 methods. So in the question, in the test, or in the exams, sometimes that we specify which method that you need to use. So if you use a wrong method, you get 0. If we specify that for you to use node analysis, but you use mesh analysis, you get 0. So you need to be able to solve the problem using all these 5 methods, because it can be basically because we can specify which one method that we want. Right? So why are we going to do this? The motivation is that if you are given the following circuits, how can we determine 1, the voltage across each resistors, and 2, the current through each resistors. 3, the power generated by each current source, for example. So what are the things that we need to know in order to determine the answers? So this is what we are going to learn in this chapter. How to calculate, how to determine the voltage across each resistors. So you have 3 resistors. So each resistors has a different voltage drop across them. The voltage across each resistors is not the same. And what is the current through each resistors? It can be the same, can be different. We don't know. And the power generated by the current source, those 2 current sources. So this is a very simple circuit. So we need to find all these values. And how to do it? We have those 5 methods. And the first one that we are going to learn today is a nodal analysis or node analysis or node voltage method. So these are the things that I mentioned that we need to know, and we have learned this last week. So things we need to know in solving any resistive circuits with current and voltage source only. So if the circuit actually consists of resistors and it has voltage or current source, then these are the 3 rules or 3 laws that we need to apply. Kirchhoff current laws, KCL, Kirchhoff voltage laws, KVL, and Ohm's law. And how are we going to apply these laws in order to find a solution? We will learn this. Okay. For example, you have that circuits. So you need to identify the branch and node voltages and the loops and mesh currents in the circuits of figure 3.1. So you need to identify, okay, the voltages at the nodes. So first, you need to identify how many nodes that you have. What's the definition of the node? Last week is the point where 2 elements, 2 or more elements met, right? So in this case, you have voltage source meet with the first resistor. So therefore, this is a node, node A. Second one, you have the resistors R1 meeting resistors R2 and resistors R3. So this is another node, node B. And resistors R3 meeting the resistors R4. There's another node. And the fourth node where the voltage source Vs meeting resistors R2 and meeting resistors R4. So there is a node D. So one of the node we indicate as a ground. So this is the sign of the ground. This. So from this circuits, there is node that we have A, B, C, and D. So how many loops that we have or mesh from last week? What is the definition of loop or mesh? It's a closed loop where you meet node not more than once. So for example, you have this loop where Vs, R1, and R2. So you go through the node A, B, and D only once, not twice. So this one loop, which we call it IA. The second one, this is the loop, which is consists of R2, R3, and R4. And another one loop is that the outer loop, this IC, which is consists of Vs, R1, R3, R4. Okay. So I1, IB, and IC. So which ones are mesh? Which one are loops? Remember the definition of loops and a mesh? Mesh does not contain any other.
mesh.
IAIB.
So the mesh is IA and IB. The loop is
IC.
So now,
I see.
what is the node voltage? VA is equal to PS, voltage of this current, this voltage source. Right? Source voltage. What is VB? VB is the current across the R2. What is VC? VC is the current across R4. VD is 0 because we assume this is a ground. We set this as a ground. Okay. So the branches voltage, this Vs is actually is equal to VA minus VD. Remember the potential, the voltage is actually the potential difference between 2 points, between 2 nodes. So Vs, the voltage Vs is actually VA minus VD. And VD is 0. So therefore, Vs is equal to VA. VR1. VR1 is basically that the voltage across these 2 nodes between A and B. And the current is flowing through from the positive to the negative. So VA has a higher voltage compared to VB. In the convention, in this convention, but maybe when you do the calculation, the answer is different. So first, actually, you make an assumption. So VR1 is basically VA minus VB. VR2 here is basically that VB minus VD, and VD is 0 because it's set as ground. So VR2 is equal to VB. And VR3 is basically that VB minus VC. VR4 is actually VC minus VD, and VD is 0, so VR4 is equal to C. So that is the voltage node. So this one actually we just introduce or identify the node's voltage. In terms of current, basically that this is one current IA, this is IB and IC. So you have three currents. In terms of node voltage, we have 1, 2, 3, and 4 for this particular circuits. And we will learn how to do those calculations later, right? By using the node analysis and mesh analysis. If you use node analysis, basically that you calculate the VA, VB, VC, and VD. If you use mesh analysis, we find IA, IB, IC. Then from there, you can find the voltage. Okay, now we go into node voltage method or nodal analysis or node analysis. So the node voltage method, once each branch current is defined in terms of the node voltages, Kirchhoff current law is applied at each node. So like for the example just now, like this example, okay, first you identify the node A, B, C, and D. So you have identify that. So let's say we take one node, VB. Remember just now we have VA, VB, and in the other one, this one was VC, and this is VD. But that doesn't matter. Let's say we have this VA, VB, VC, and VD. So, by Kirchhoff current law, we say that the summation of a current entering and leaving the node is equal to 0, right? From last week. Yes. So from this diagram, the current is flowing from plus terminal to negative terminal. So if you indicate R1 is plus minus here, R2 is plus minus here, and R3 plus minus there. So therefore, the current of I1, which is the current flowing through R1, is entering the node. And the current flowing through the R2 is leaving the node VB. And same thing with the current I3, which is flowing through R3, is leaving from VB. So therefore, we can write the formula as I1 minus I2 minus I3 equal to 0. Yeah. In the node voltage method, we express the KCL by this term. Remember just now that we say that the voltage across R1 is VA minus VB. Okay? Remember?
Yes.
Okay. So basically that V R1 is equal to VA
minus VB
minus
VB.
VB minus VB. So it is the voltage, but we want the current. This I1. This is the term for I1. So what is the Ohm's law says? V equal to
IR.
IR. So therefore, I is equal to
V over R.
Over
V,
R. V
V
over R.
over R.
R.
Okay. So the voltage is VA minus VB divided by, what is the R? Is R1. So this is actually term for I1. Yeah. This is entering. So positive sign. Now this one is I2 is leaving. So what is the voltage? Voltage is really VB minus VC divided by R2. So this is actually I2. Minus because it's leaving the node. And this one is the I3. Okay. and the sign is minus because leaving the node. So this is the equation for this node. So in the node voltage method, we assign the node voltage VA and VB. The branch current flowing from A to B is then expressed in terms of the node voltage, I equal to VA minus VB over R. So this is actually what I have explained here. Okay? So we are going to use this method to solve our problem. So simple, but you need to understand this, that how to set up the equation for each node. Okay? Any questions so far? No
No,
question.
sir.
Okay.
No, sir.
This is the method that you need to go through. The node voltage method is based on defining the voltage at each node as an independent variables. Okay. So one of the nodes is selected as a reference node. So usually the ground, and all other nodes voltage respect to that node. So you assign the voltage V1, V2 up to Vn minus 1 to the remaining n minus 1 nodes. So basically that the first step, you identify how many nodes that you have. Let's say you have 4 nodes. So therefore, from the 4 nodes, one node you define as reference node, as the ground. So now you live with 3 nodes. So that 3 node, you assign the voltage V1, V2, V3, or VA, VB, VC. Right? It's depending whether you define it as A, B, C, D, or you define as 1, 2, 3, 4. Right? So assign the voltage V1, V2, and Vn minus 1 to the remaining n minus 1 nodes. The voltages are referenced with reference node. Okay? Once each node voltage is defined, Ohm's law may be applied between any two adjacent nodes to determine the current flowing in each branches. So basically that you define the current as V1 minus V2 over R, or VA minus VB over R, depending on that branch, that element is in between which node. If it's in between node AB, then VA minus VB divided by R. If that branch is between VA and VC, so therefore VA minus VC divided by R. So you see the N nodes, it has 2 N nodes. So one minus the other divided by the resistance in between the node. Like this. Basically, this one node, then this is the element. So the current, basically that's node 1 minus node 2 divided by R. Right? Then you apply the Kirchhoff current law to each of the nodes in terms of the node's voltages. So the summation of the current at the node is equal to 0. Then you solve the simultaneous equation to determine the unknown node voltage. Why simultaneous equation? Let's say you have 4 nodes. So therefore, you have 3 equations because you have V1, V2, and V3. That is as an independent variables. So you have 3 equations. So you need to review on how to solve the simultaneous equation. But now I think in the calculator, you can just plug in the coefficients, right? And you can get the answer. Very easy. So if you have 4 nodes, A, B, C, D, and D is being the ground, so therefore you have A, B, C as a variables. So 3 variables, you have 3 equations. So you have to solve these 3 equations simultaneously to get the answer for VA, VB, VC. Okay. This is the step one. Let's say you have these circuits. So you identify how many nodes. This one node, this one node,
See here.
this is one node. Okay. So now you have three nodes. So one of the node you assign as a reference node. So as a ground. You take the one with the many branches as a ground. Or one is that connected to the end of the current source or voltage source. Okay. Normally. So you have three. This is actually can be redraw as this because sometimes students get confused by this. They don't see this as one node. Sometimes they put this is another node, this is another node, which is wrong. Because you cannot do that because there is no element here. Because there is no element. It's just a wire. So these circuits actually can be redrawn as this. Then you can see clearly this is actually one node, this is one node, this one node. So this one assigned as a ground, so automatically is a 0. A ground, the value is 0. So therefore, for node A, then current going is IS because this is a current source, and going out is basically I1. I1 is equal to VA minus VC or minus 0. So VA divided by R1. This one VA minus VB divided by R2. And this one is VB minus 0 divided by R3. So that is the equation. So you have equations. VA over here, basically your IS minus VA over R1 minus VA minus VB over R2, one equation. Another equation is that you have here VA minus VB over R2 minus VB over R3. So you have two equations because you have two independent variables, VA and VB. If you have three nodes, then you have two equations. If you have four nodes, you have three equations. If you have five nodes, you have five equations. If you have five nodes, then you have four equations. If you have six nodes, you have five simultaneous equations. So the more complicated your circuits is, the more equation that you have. So the equations, the simultaneous equation that you have is n minus 1. So if you have n number of nodes, therefore you have to solve n minus 1 simultaneous equation. Example. This is actually the first diagram that we show you just now. Circuits with the independent current source. So you have two current source, which is 1 ampere and 4 ampere. One is flowing up, the other one is flowing down. And you have two resistors, 2 ohm, 6 ohm, and 7 ohms. And first, you need to identify the node. So you have one node, second node, and third node. So from here, you set node 3 as a reference node, as a ground. Okay. So this is actually equal to 0. Now, so this one, you name it as V1, and this one, you name it as V2. So you need to obtain the voltage in the circuit. So you need to calculate for V1 and V2. So what is the formula that the KCL, the KCL at this node? So you get this one is going here, and this one going out. This one is going out because you put plus sign here, minus here, plus sign here, minus here. This one you can put plus here, minus here. Okay, so this is going out. So the formula is that if you calculate, if you write the formula here, then you have 1 minus V1 over 2 minus V1 minus V2 over 6. That is the first equation for this. Second one, what is the equation of this? So you have going here, going in, you have going out here, and you have going out here. So what is the form? What is the equation? V1 minus V2
2 over
over 6 minus, what is
V2
this one? V2 over 7
over 7 uh,
minus 4.
minus 4
over 7
over 7 plus 4
minus,
minus 4
going out.
minus oh sorry sir,
This is actually equal to
0
0. This also equal to 0. So now, what you need to do is that you need to rearrange this equation so that you have in terms of V1, V2 equal to something, and this also V1, V2 equal to something. Then you can solve your simultaneous equation. Can you get this answer? Can you try? Can you get this answer?
Yes, wait.
Yeah, I give you 3 minutes to do. Okay. Everybody got it? Dapat tak?
Yes.
Everybody? Dapat?
On the way, sir.
Okay. Siapa yang dah dapat? Atau tak dapat? Okay. Everybody got it?
I got V2 equal to 8.9.
Naik mana boleh. Cuba buat apa ni. Equation balik. This one actually you akan dapat 6 minus 3 V1 minus V1 minus V2 equal to 0. So 6 minus 4 V1 minus V2 equal to 0. So 4 V1 minus V2, basically 4 V1 plus V2 is equal to 6, right? The first equation. So So 6 minus 4 V1, 6 minus 4 V1 minus V2 equal to 0. So therefore, V1, 4 V1 plus V2 equal to 6. First equation. Second equation. Second equation, you have V1 minus V2 divided by 6 minus V2 divided by 7 minus 4 equal to 0. So you get 7 V1 minus 7 V2 minus 6
V2.
V2 minus 4 times 6 times 7. Equal to 0. So berapa?
168. So
7 minus 13 V2 plus equal to
7 minus V2 minus 168. 0.
berapa? So you need to solve those two simultaneous equations. The first 4V1 plus V2 equal to 6. So V2 is equal to 6 minus V1. So you substitute that into the second equation. So 7V1 minus 13 times 6 minus V1 equal to 2, 7. So kira-kira, dapat tak? 7V1 minus 13 times 6 plus 13V1 equal to 24 times 7. So 7, so 20V1 is equal to kira-kira.
Dapat saya jawapan dia sama macam jawapan dalam tu.
Siapa yang dapat?
Saya Nazmi. Saya dapat jawapan sama.
Okay. So now you know how to do lah. So 20 lepas tu kejap saya punya calculator ni pun patutnya akan dapat lah. 13 times 6 78 plus 24 times 7 dapat. Okay. So that is how you do it. Okay, now example number 2. Solve for all unknown currents and voltage in circuit VIDO. This is example 3.2 in Risoni. So from the schematic diagram is given, and data given is that I1 is 10 milliamps, I2 is 50 milliamps, R1 is equal to 1 kilo ohm, R2 is 2 kilo ohm, R3 is 10 kilo ohm, and R4 equal to 2 kilo ohm. So these are the values. So now, what is the first step that you need to do?
find how many nodes, sir?
Okay, so how many nodes that you have?
1, 2.
6.
Are you sure 6? Redraw.
5. 5, sir.
You sure?
4 notes, sir.
1, 2, 4 nodes.
Yes, 4.
You sure? This
Yeah.
one node. Okay. So this one node, right?
Yes.
Right, sir.
This
3 nodes, sir.
node. So you have
You know.
3 nodes. Okay. You have 3 nodes. 3 nodes, then you have 2 equations. For the node 1, current going to the node, this current out of the node, current out of node, this current out of the node. So I1 is going in, and this is, let's say we call this I2. So V1, we call this V1. This node is V1, this node is V2. Okay. V1, I1 is going into the node. This one is IR1 going out, IR2 is going out, and IR3 going out. What is IR2? IR2 is V1 minus 0 divided by R1. Here. And this is IR2, basically V1 minus V2. This is node V2 here. Okay? Divided by R2 here. And 3 is V1 minus V2 divided by R2 equal to 0. So this is the first equation. The second equation is you have IR3 is going into the node 2, IR2 is going into the node 2, IR4 is going out from node 2, and I2 is going out from the node 2. So we have V1 minus V2 over R2. This is actually IR2. And V1 minus V2 over R3. This is actually IR3. And V2 minus 0 divided by R4. This is IR4. And minus I2 going out. So we have this equation. So you rearrange the equation so that it's written in the form of V1 and V2. So you arrange this, you get 1 over R1 plus 1 over R2 plus 1 over R3 V1 plus in the bracket minus 1 over R2 minus 1 over R3 times V2 is equal to I1. So this actually, you rearrange this equation, right? And this, you rearrange this. So you solve this simultaneous equation. So basically, first you plug in the values of R1 and also I1, R1, R2, R3 into this formula. So you get this equation, these two equations. So this is this, and this one is this. And you solve this simultaneous equation. So you get this answer. V1 is equal to minus 13.57 volt and V2 equal to minus 52.86 volts. Okay? Clear? Boleh
Yes,
buat? Huh? You go
Okay.
through this on your own time. Eh?
Yes, sir.
You can go through this. But this is how you solve the nodal analysis.
Okay, sir.
What time is it now?
12 o'clock.
12 o'clock.
Yes, sir.
12:04.
Yes, sir.
So we have another 1 hour. Eh?
Okay,
Sir.
sir.
So you want a break?
Take 10, sir.
10 minutes.
Take 5.
Yes, sir.
5, okay.
Take 10. Sir.
5 minutes. 5 minutes. Because
10 minutes.
Astagfirullahaladzim.
5 minutes.
Berapa minit sudah?
Alright, sir.
Okay.
5 minit.
Very high, sir. Very high.
So we'll come back at 12:10.
Alright, sir.
Okay. Okay, semua dah ada.
Ada yang bagi tanda sir?
Okay. 2 minit lagi. Okay, we continue. Any question on this? On the example 2?
No, sir.
No. Okay. So this one actually you can do on your own to get a more clear understanding and how the process from setting up the equation for node 1 and node 2 and doing some algebraic manipulations to come up with the two equations with the independent variable of V1 and V2, then using the simultaneous equation method to solve to find V1 and V2, right? Okay. Example number 3. Write the nodal equations and solve for the node voltages. This is also an example in textbook 3.3. You are given the circuits as IA, the two current source, which is IA and IB, and 3 resistors, R1, R2, R3, and R4. And the value given as IA as 1 milliamps, IB as 2 milliamps, R1 is 1 kilo ohms, R2 is 500 ohm, R3 is 2.2 kilo ohm, R4 4.7 kilo ohm. So from here, how many nodes that we have? Can you identify the node?
3.
Wait, okay. 3. So this one, these 2, and these 3. And this one set as the reference node. Right? Okay. So this is the solution. So the equation for at the node A, and we call this a VA. So VA is actually that you have IA flowing to the node, into the node, and I1 is going out and I2 is going out. So IA going in positive, I1 is going out, so minus VA minus 0 divided by R1 and minus VA minus VB divided by R2. So this is the equation for node at the node A. This is the KCL at the node A. At the node B, so you have how many currents? 1, 2, 3, and 4. 4 currents. So therefore you have 4 terms here. So the first one is I2 is flowing into the node B. So therefore VA minus VB divided by R2, this one. And you have IB flowing into the node here. And we have I3. I3 is basically that VB minus 0 divided by R3, and I4 is VB minus 0 divided by R4 equal to 0. So this is actually for node B. And you rearrange the equation. So you have 1 over R1 plus 1 over R2 times VA plus minus 1 over R2 times VB equal to I1. So this equation rearrange, you get this. And the second equation, you rearrange, you get minus 1 over R2 VA plus in the bracket 1 over R2 plus 1 over R3 plus 1 over R4 times VB. This actually equal to 0, equal to IB. I think I missed the what call it here. I will adjust the slide later. And from here, so this actually equal to IB minus IB. So you plug in the value given, you get this equation, and this one you get this equation. And from here you get this. 3A minus 2VB equal to 1 and minus 2VA plus 2.67 VB equal to 2. And you solve a simultaneous equation, you got VA is equal to 1.667 volts and VB equal to 2 volts. Okay, you do this on your own, the working, in order for you to understand, to get a clear understanding. Okay, any question? Tada?
No, sir.
Ada sir.
No, sir.
Okay. Solve the circuit equation in example 4 using Cramer's rule. Actually, I'll take this example actually here. The same example using the Cramer's rule. So what you do is that you take this equation and you set up in a matrix form. This is actually this coefficient. This actually this coefficient minus 2 is this coefficient. 2.67 is actually this coefficient. Then you put VA and VB is equal to 1 and 2. So this here, this here. So you set up this. If it's 3 by 3, but also the same. If you have 3 equation, then you have 3 by 3 matrix here. This matrix. This matrix depending on how many variables that you have. And from here, you can use Cramer's rule, because some of the exam that we ask you to solve using Cramer's rule, for example. right? In order, if you want to read about Cramer's rule, you can go through this website, for Cramer's rule, the details on the Cramer's rule. So if you want to find VA, therefore you take the determinant of what you do is that you replace the coefficient of VA with the, for VA, basically that you replace this coefficient with this. You replace that here. So 1, 2, you replace the 3 minus 2. This one, coefficient for VB stays. So you take the determinant, divide by the determinant of the original matrix. So, and then you calculate. So you get 1.667 volts. For VB, the coefficient for VA stays, and you replace the coefficient of VB with the 1, 2 here. And you divide by the determinant of the matrix. So you get 2 volts. So this is how you use the Cramer's rule to solve the problem. If you have 3 by 3, then you have a 3 by 3 matrix. So let's say it's VA, VB, VC. So the coefficient, if you want to find the VA, then you replace the VA coefficient, and then coefficient of VB and VC stays, divided by the determinant of the matrix. So you calculate. Okay. Example 4. Solve the circuit using node voltage analysis. This is also in the textbook. You are given these circuits, and you are given the value of I1, I2, R1, R2, R3, and R4. R1 is 2 ohms, R2 is 1 ohm, R3 is 4 ohms, R4 is 3 ohms. I1 is 2 amps, and I2 is 3 amps. So 1, 2, 3, and 4 nodes. One node is set as a ground, so you have 3 nodes, so therefore you have 3 variables and 3 equations. So for the V1, you have I1 is flowing out from the nodes, and I2 you can assume is going in the node, and I3 and flow into the node. Okay. So basically that for this one, this is plus, this is minus, this is plus, this is minus. So the equation is that you have V3 minus V1 divided by R1 plus V2 minus V1 divided by R2, and going out is I1 equal to 0. So this is the equation at this node. Node 2. Node 2 is basically that you have V1. So now this is for this one is it assume this is going in. Okay. So V1 minus V2 divided by R2, and V2, this is going out because it's that plus minus. So minus V2 divided by R3 and plus I2 is going in equal to 0. So this is this node. I can also use the original convention and that we use what we call it originally going out. You can also do that. It's no problem. I prefer to stick my convention instead of changing for each node, right? But this since this textbook using this, so I follow the textbook. You can also use this as going out. So basically, I can put a. This is actually same thing, because I can put a minus V2 minus V1. So when minus, it becomes this. I can do that also, right? And this one, this consider as what I call it, going this way. So V1 minus V3 divided by R1, going out, V3 over R4, and this is going out, minus I2 equal to 0. That. Okay. So this is the equation. 3 nodes, 3 equations, and you have 3 variables, V1, V2, and V3. Okay. Then you simplify, so you get this equation. Okay. And you can what do you call it, solve the equation by doing the simultaneous equation solution. So V1 is equal to 4V1 plus 12 divided by 5. So from this actually you get this, and this one actually from here. So V2 and V3. So you substitute this into node 1. So this actually you substitute in node 1, in the equation node 1, then you get this. So you get the value of V1 minus 3.5 volts. So when you get minus 3.5 volts, then you can substitute into this equation, then you get the value of V2 of 0.4 volts. And this also you can substitute into that. So you get V3 is 0.57. And the question is asked you to find this value, the voltage across R3. So the voltage across R3 is V2 divided by R3. So you get this V2. And that is the current. V2 over R3 is the current. So the voltage is really is equal to V2. So V is equal to V2. So minus 0.4 volts. Okay? Clear?
Clear, sir.
So I'm going to cover the nodal analysis today. So next example, I'm giving you a lot of examples. Using node voltage analysis, find the voltage V1 and V2 for the circuit shown. So basically that you have 3 nodes, V1, V2, and the ground. So you have going in, going out. You can do going out there. Plus here, minus here. So 4 minus V1 over 3 minus V1 minus V2 over 1. This one equation. The second equation for this, do I have the solution? Okay. Simple. I just show here. Okay. So basically that I has IS minus I1 minus I2. So 4 minus V1 over 3 minus V1 minus V1 over 1 equal to 0. So this is the first node. The second node, I have I2 minus I3 minus I4. What is I2? I2 is V1 minus V2 over 1. What is I3? Minus V2 over 2. What is I4? Minus V2 over
1.
no, because you have two resistors here. So in series, what happened to the resistor in series?
Oh, okay.
You add. Remember?
Remember sir, R plus R.
Okay. So that's why you get this
Two.
is actually 2. So this value is actually 2 ohm because it connected in series. So you rearrange the equation. So you get for node 1 is 4 over 3 V1 minus V2 equal to 4. And node 2, you got V1 minus 2 V2 equal to 0. So from node 2, you get V1 equal to 2 V1. So this one you substitute into node 1. This you substitute into here. You get this. So 5 over 3 V2 equal to 4. Therefore, V2 is equal to 2.4 and V1 equal to 4.8 volts. That's how you do. So don't get cheated by this. Sometimes we do this, right? Don't get confused by that, right?
All right, sir.
Okay.
Yes, sir.
And sometimes we can also say this, okay? We have V1, V2, and actually this is another node. Can also. So this is V3. But now you have 3 variables, which is actually is not needed, but you can do. So 3 variables, 3
No.
unknowns. So you have 3 equations, simultaneous equation.
Yes.
It's a bit more complicated, but you will get the answer also. But the simplest one is that you can combine this because the question is that you want to find V1 and V2. So this actually, based on your knowledge of series resistor, you can combine this to be one resistor, which is 2 ohms. 2 resistors in series. Okay? So you need to be careful, right? Okay, another questions. Now you have to find the currents here, this current through the voltage source. So how many nodes that you have? 1, 2, 3, and
4.
4 nodes. You have 4 nodes. Okay. So you call V1, V2, and V3. And this is the ground. Ground, right? Now you apply the KCL at node V1, V2, and V3. Okay. So at node V1, this is going in, and going out. So going in, the first one is V3 minus V1 divided by 0.5. Second one is V2 minus V1 divided by 0.5 and minus 2 amps equal to 0. So this is node 1, node V1. For at node V2, you have going in. We assume that this is going in. So you have 0 minus V2 divided by 0.25 here. And you have V2 minus V1 divided by 0.5 and minus I. This is what we want. I equal to 0. This is the at node 2. At node 3, V3, you get I is going into the node minus V3 minus V1 over 0.5 minus V3 minus 0 divided by 0.33 ohms here. Okay. So from node 3, you can simplify the equation. So I is equal to V3 minus V1 over 0.5 plus V3 over 0.33. So you simplify the node 3, you get this. So that this one you can substitute into node 2 equation. Rearrange the node 2 equation by substituting the value of I just now. You get this minus V2 divided by 0.25 minus V2 minus V1 0.5 minus V3 minus V1 over 0.5 plus V3 over 0.33 to 0. So you write the system equation resulting from the application of KCL. So at node 1, just now you rewrite. You get minus 2 V1 plus V2 plus V3 equal to 1. Node 2 here, this one, you rewrite, you get this. And we know that V3 equal to V2 plus 3 here. We know that V3, the voltage here, is actually V2 plus V3 plus here from this. Therefore, we can substitute this V3 with this equation. So node 1 becomes this when you substitute this, and node 2 becomes this when you substitute the V3 here. So V2 is equal to V1 minus 1, and you simplify this. You get minus 7.03 V1 is equal to 4.01. So V1 therefore equal to this. So you get the value of V1. Then you can calculate for V2 and you get minus 1.578 volt, and V3 you get 1.422. Therefore, you can calculate the through the voltage source, because now you have the value of V1 and V3. Okay? So the current is 8.309 amps flowing through the voltage source. Okay? So sometimes the students actually, they were so engrossed in solving the node voltage, they forget that the question is actually asking you to find this. Sometimes students will forget the question. And in order to get full marks, you need to show your workings. You cannot just give an answer, oh, I is equal to this, without showing how you get the voltage of V1, V2, V3, without going into that process. So you will not get marks if you just get, okay, I is equal to 8.309, without going through all this process, identifying the voltage, the node, setting up the equation at the node V1, V2, V3 using the KCL, without doing the simultaneous equation solution. So if you don't follow this process, you will not get marks. You need to follow through the process. Then after that, you have to find the answer to the question. All these actually carry marks. Maybe, for example, this question carries 10 points. So the answer this, maybe just 1 point, but this carry 1 point, this 1 point, this may be 1 point, 1 point, this may be 1 point, and setting up of this maybe this 1 point, 1 point, 1 point, right? So those actually you have to collect marks throughout your process in solving the problem. Okay, that is actually on the nodal analysis. I'm going to stop here for today, and we continue on mesh current method on another lecture, because I need you to to process, to make sure that you understand nodal analysis first before we go into a new method. Not too much for you. Okay.
All right, sir.
Okay. So any question on the nodal analysis?
No, sir.
No, sir.
All understand? All clear?
Yeah.
InsyaAllah.
Okay. And if you make sure that you go through the examples. You go through the process, because some of the calculation I skip, remember. So you need to go through on your own. And if you have any question, tomorrow we go. We have 1 hour tomorrow. That for you to ask me any question on the nodal analysis. Okay? From chapter 1 up to the nodal analysis tomorrow. Okay? Next,
Okay.
current
All right,
method,
sir.
I will do it next. Okay?
All right,
Okay,
sir.
sir.
Right, sir.
Now is stop sharing, and if you don't have any question, then I'm going to stop the recording, and we can stop our lecture for today. And I'll give you time for you to digest what we could today. And tomorrow you can ask me for clarification.
All right, sir.
Right,
Thank
sir.
you. Have a nice day, and see you tomorrow at 3 to 4. Okay. Thank you.
Thank you, sir. Assalamualaikum.
Thank you, sir.
Assalamualaikum. Bye.
Salam, sir.
Thank you.